So in this video, we'll be discussing differential equations. So to start off, it's important to define what a differential equation is. So a differential equation is a mathematical equation that relates a function with its respective derivatives. Specifically, it often involves one or multiple derivatives of a dependent variable with respect to one or more independent variables. In essence, it's basically how a function changes as its input changes. When we specifically discuss differential equations, there's only two differential equations that we really would get into. And that's when we discuss direct, proportional, and inversely proportional differential equations. So with directly proportional differential equations, it's important to understand that if if a variable a, let's say a variable a, is proportional to variable b, then we can display that as a differential equation such as a is equal to k times b, where k is a constant. And you probably discussed directly and inversely proportional equations back in pre-calc, so this shouldn't be all too new to you. While with inverse proportional, you're often given a scenario where let's say variable a is inversely proportional to variable b. In this case, the variables are inverse of each other. They're an inverse of each other. So this would be depicted as a is equal to k over b. Or you could also rewrite this as like k times 1 over b. But they mean the same thing, right? Where the variable of a is inversely proportional to event b. So understand that there's often they're referred to differently. So sometimes with directly proportional, you'll often hear just the word proportional. So when you just hear proportional, you can assume that they're referring to directly proportional. While with inversely proportional, you often hear proportional to the reciprocal, and it's likely referring to this. This is like what you would see in textbooks most of the times. So as long as you have this knowledge, creating or modeling situations with differential equations should be pretty straightforward.
Let's do the
In this problem, we're not given specific. In this problem, we're not given a specific scenario. Rather, we're just trying to focus on how to set up a differential equation without background knowledge or an actual application. So we can start out by understanding, is this directly or inversely proportional? So here we're told the product. So we know there's going to be multiplication, and we're told proportional. So we can right just from that we can assume it's directly proportional. So we know that the rate of change, d of a over d of x, it would be with respect to b. So it would be the rate of change with respect to b would be dA over dB would be equal, and then as previously discussed, directly proportional often is rewritten as a is equal to, or variable a is equal to the constant k times variable b. So because again we're not given the context of any of these variables, we just write k, and we're assuming k is our constant. It's proportional to the product, so there's going to be multiplication of x, and so we're going to multiply again the rate of d of z over d of b. Now, this is a bit unusual because there's no numbers, so it's a bit unorthodox from your usual calculus. But the point of this word problem was just to understand how to set up and structure, or how to actually model a possible scenario with differential equations. So let's move on to an actual example with actual context. So in this specific word problem, it reads the force. So in this specific word problem, it reads the force F of a spring on a trampoline can be related to the distance d it is stretched. So we're applying differential equations to an actual context. So we're told the force F of springs in a trampoline and the distance, the stretched distance of the springs. The rate of change of the quantity of F with respect to distance d is inversely. So we're told inversely. So we're going to have a scenario where variable a is equal to k over variable b, right? This is going to be our differential equation because we're told it's inversely proportional to the natural log of the distance d. And then we're given actual values. So if the rate of change of F is 5 units per centimeter, then the spring has been stretched 1 centimeter. Okay, so initially we're told that the rate of change of the quantity of F, so d of F with respect to the distance, is going to be equal to to the to the reciprocal, the natural log and the distance. So just as we had it here initially at the start of the video, how we mentioned inverse proportional. We're going to have k, so our constant, we don't know what our constant is, so we just write it as k, is going to be over the natural log of d, and that's our differential equation. However, we're not, if we were just given this context, if we weren't given actual values, then we can just call it a day and this would be our answer. But because we're given actual values, we can solve for k, right? So if we know that the rate of change, so if we know that the rate of change of f over d of k is equal to 5, and we know that the spring, so we know that distance is equal to 1 centimeter, we can solve for k by plugging in our values. So we have 1 is equal to k over the natural log of 1. So we can multiply both sides by the natural log of 1, natural log of 1, and we're left with k. Then we're left with k is equal to the natural log of 1 times 5. Now, I don't have a calculator with me, but if you do, you could simplify the natural log of 1 times 5 and then plug that back into the original differential equation, which you should have had. D of f over d of d is equal to k over the natural log of d. Now that you have your k value, you can plug that into that k value. So then your final answer or your differential equation to the problem should be d of f d of f over d of d is equal to the natural log of 1 times 5 over the natural log of d. And that is your answer. Hopefully, this gives you a better understanding of how to model scenarios or situations with differential equations, and hopefully, you understand the difference between directly and inversely proportional. As we mentioned, directly is when you have an event event or variable a is equal to the constant times the event or variable b, while inversely is when event A or event B, is equal to K over B over event or scenario B.